Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Lesson 4-5 for Course 3. The section is entitled Similarity Transformations. Our objectives are to graph dilations and determine the scale factor of a dilation. Okay, so we do have a few vocabulary terms that we want to take care of before we get started. A dilation is a transformation in which a figure and its image are similar. Okay, so if you go back to the definition of similarity from our previous section, means the angles will be congruent and the corresponding sides are going to be proportional. Dilation, well, I'll have a couple more things to say in just a moment. The scale factor is the ratio of a length in the image, and the image is the new picture or the new shape, to the corresponding length in the original figure. I usually make a little note to myself. The ratio is image to original, so I over O. If you want to add that in your notes, you can. It just helps me remember that that's what I'm trying to do. Okay. An enlargement is a dilation with a scale factor greater than 1. Running out of room here, greater than 1. Okay, most of us probably think about, when we hear dilation, we think about the enlargements because we get our eyes dilated. That means the doctor enlarges our pupils. Okay, so a dilation in which basically something is made larger also is an enlargement. A reduction is defined as a dilation with a scale factor less than 1. Okay, so when you shrink something or reduce it, that is also mathematical for dilation, but it just makes it smaller. Okay. All right. Finding a dilation. Find the image of triangle ABC after a dilation with center A and a scale factor of 3. Okay, so center A means basically A is going to stay home, and from out there things will be adjusted. Okay, so because we have a scale factor of 3, you basically have to study this diagram and figure out what it is you need to do. Oh my. Oh, sorry, my computer went black there for a moment. I forgot my screen went to sleep. Okay, triangle A prime, B prime, C prime is the image of triangle ABC after a dilation with a scale factor of 3. So they're going to be similar. Let's go now, though, and look at our information. Since A is the center of dilation, A is also equal to A prime. They're going to be in the same position. Remember, the prime indicates the new location. Let me make this a little bit larger. Okay. Because there is a scale factor of 3, A prime C prime is 3 times the length of AC. So A prime C prime is equal to the scale factor of 3 times the length of AC. Okay, so that's going to make A prime C prime equal to 9. And I'm just going to jot that over here because really in this box we don't want to put a 9, okay? We want to put a 6 because then 3 plus 6 gives us the 9 for the larger triangle. Also, upon dilation, this point is now C prime. Same process down here. A prime B prime is 3 times AB. So A prime B prime is going to be the scale factor 3 times the length of AB, or 3 times 2, which is 6. So all across here, A prime to B prime, this is B prime, is going to have to total 6. So 6 minus 2, that means this piece from here to here is 4 units. Okay? So A prime B prime is 6 units long. This little section here is 4. I would go back through this and try to be sure that you understand everything. Bring your questions into class. Definitely want to understand what this is. So look back through it. Be sure that if you have any questions, you bring them in so we can clarify anything that you're confused about. Okay. This is a quick check question for you. I'm going to leave it to you to do, and again, bring in questions with this as well. But let's go on to example number 2. Graphing dilation images. Find the coordinates of the image in quadrilateral W, X, Y, Z after a dilation with center 0, 0 and a scale factor of 1/2. Quadrilateral XYZ has vertices -2, -1 for W. X is 0, 2, Y is 4, 2, and Z is 4, 1. Our first step is to multiply each of the X and Y coordinates by 1/2, since that is our scale factor. So you can probably do a little mental math there. -2 times 1/2 is -1. -1 times 1/2 is -1/2. 0 times 1/2 is 0. 2 times 1/2 is 1. 4 times 1/2 is 2. 2 times 1/2 is 1. 4 times 1/2 is 2. And -1 times 1/2 is -1/2. If you need to write that math out, certainly you have room here on the side to do that as well. So now what I want to do is go in and plot my new ordered pairs so that I then have that dilation. Okay, so W now becomes -1, -1/2. So it's right about here for W prime. Okay, then X becomes 0, 1, so over 0, up 1. So this is now X prime. Not a lot of room here, sorry. I'm trying to do it in ink so you can see. This is X prime. Y prime is 2, 1, so over 2, up 1. That's Y prime. And Z prime is 2, -1, so over 2, -1/2. So that's actually smack dab on that 2 there, for Z prime. And then connect your ordered pairs. And what you see there is a dilation. If you had to describe this dilation, it would actually be a reduction because it is smaller than the original picture or figure. Okay. Let's look at number 3. Number 3, we're actually finding our scale factor. triangle Q prime, P prime, R prime is a dilation of triangle QPR. Find the scale factor. Is it an enlargement or a reduction? Okay, so what you need to do here is you need to find two corresponding sides, and basically using the idea that we're going to take, it's the ratio of the image to the original. So if I do Q prime, P prime, okay, that is actually 4 plus 2 units long. 4 from here to here, 2 from here to here, over QP on the original, which is 4. So that actually gives me 6, 4 plus 2 is 6 over 4, which reduces to 3 over 2, or 3 to 2. The scale factor is 3 to 2, or 3 halves. It is greater than 1. So the dilation above is an enlargement. In other words, the new figure is larger than the original figure. Okay? You have a couple more quick checks on this page. Please be sure that all 3 are completed before we meet again in class. I look forward to seeing you then. Thank you.